Greetings, fellow grade 10s. It is Mr. Hlajai here. Welcome to Back to Basics, right? So what we are doing now, we are doing factorization, right? We are just, revising some of the important concept that we have when it comes to factorization, right? So please ensure that you have watched part A of this particular video so that you can have a proper understanding in terms of what is it that we do here whenever we are factorization, or rather whenever we are factorizing. Yes. Right. Now let's look at this. Now, number 6. So in number 6, you are having 27 a cubed subtract this is going to be ab squared. Are we fine, right? Now, what is the best thing that we can do now from here? So between this, I want you to look at this, right? Can you see that from let me write this one here. This is 27, this is a, this is cubed, this is subtract 3, this is 8, this is b squared, right? Now, I want you to look at this. Can you see that from this, right? Can you see that from this, we have what we have our factors of 3 from both, right? So which means firstly, we can take out 3 as a common factor, which means we are going to take out 3 as a common factor. Is 3 the only common factor here? No. Now we also have a, right? Because even here there is a, right? Which means we are going to have 3a. Now, what is that you're going to remain with from here? This is going to be same as 9 because 3 multiplied by 9 gives us 27, right? So this is going to be a squared because the other a is outside there, right? Remember laws of exponents. When you multiply powers of the same base, you add the exponents. That's why it's going to be 3 to the power of 3 altogether when you multiply back. Now, this is going to be subtract. What is it that you are having here? Already you've taken out 3 as a common factor. You've taken out a as a common factor. You are only left with b squared. Are you together, right? So you are only left with b squared, which is in here. And now with b squared, what is it then that you're going to do? Which means now you're going to say this is 3a into what is going to be this one that we are finding here, right? Now, can you see that this is a different of 2 squares? Can you see that this is a different of 2 squares? Because 9 is a square number, a squared, it is squared, right? And b is also squared, which means now, how do you then write this one? Can you see that now there's the square root of 9, it's same as 3, right? And then the a is going to be a, right? Even in this side, it's going to be 3a. And then what is for b? This is going to be b. And also this is going to be b, which means this is going to be plus minus your b, which is going to be the solution for this particular answer, right? How to get, right? Now, so firstly, now that's what you are going to have. Now, I want us to look at our number 7, right? Number 7 now here. And this is a factorization of cubes, right? Now, I know this, we might have not seen it, no, look, what is it that we do in factorization of cubes? Look, this is 27a to the power of 3. Now subtract 1. Now, why am I saying this is different of 2 cubes? Because firstly, a is cubed, right? A is cubed. And now 27, it is also a cube number. When you go back to our number systems, 27 is a cube number. And when you look back at 1, also our 1 is a cube number because when you have 1 to the power of 3, it still gives you 1. Out again. Now, we have a special formula here, right? So we have a special formula of that we use when we factorize our cubes, right? So we have our special formula that we use whenever we factorize our cube, right? What is it then that you are going to do here? We are going to start here. So this is what we are going to use in our formula. This, now let's say for an example, we have this. Let's say we have a to the power of 3 subtract b to the power of 3. All right, again. Now, what is it then that you do here? You start here. Now, this formula, it states that now, if you want to factorize the cube, firstly, you are going to start by looking for the cube root of the cube root of the first of these two terms, right? So what is this going to be? Which means now here, this is going to be same as what? This is going to be same as a, subtract my what? Subtract my b. And then now, what else then now I am going to have from here? Now I am going to have this. Now I am going to have my first term, right? as squared, and then the second term is going to be same as what? The second term is going to be same as what? This is going to be there now plus a multiplied by b, right? And then this is going to be plus what? This is plus b squared. Out again. Now, this is the formula, right? So I am saying now, if here you're having a squared subtract b, now this one and this one both must be negative, and everything within the bracket must be what? It must be positive. Oh, it's okay. Now, this is the formula that we are always and constantly going to use whenever we factorize the cubes, right? Now, let's say you are having now two positive cubes. Let's say you're having a to the power of 3, and then this is plus b to the power of 3. What is it then that you're going to have, right? So just like I said in the beginning, what is that you're going to have here? Now, you're going to have the first bracket. The first bracket is going to have your first term here, the square root of the first term, which is going to be your a. And then it's going to have plus now the square root of the second term, which is going to what? Which is going to be b, right? So which means the sign here, it's always going to be the same here. It's same sign here. Again, and then here, this is always going to be a plus, and also this is going to be plus plus, right? What this sign here, it is always going to be positive, right? Whatever that you are going to have here is always going to be positive. But now let's look at this one. Now, so from here, what is it then that you are going to have? Right? So now in here, we are going to then start from here. Remember, here we are having what? Now we are going to also have a squared. This now, remember the sign that you have here must always be the opposite of the sign that you are having as your second term here, right? So this is going to be now minus ab. And then the last term is always going to be what? It's always going to be b squared, right? And it's always going to be the positive b squared, which means now here, this must always be the opposite sign, right? The opposite sign, right? And then, which means, can you see even here, if this was negative, this one is always going to be what? The opposite sign, right? How to get. And then this one, it's always going to be what? It's always going to be positive in whatever that you are having, right? So now, what is it then that you are going to do? Now, let's look at the 27 and apply these things that we have on the side, right? Let's start here. Now from here, look at this. Now I am going to start by obviously opening up the small bracket, right? And the bigger bracket, right? So in the small bracket, remember 27 is a cube number. And what is the cube root of 27? Can you see that this is going to be our 3, right? And what is going to be the cube root of a? This is going to be a. Oh, it's okay. And now what is going to be the cube root of 1? This is always going to be what? 1, right? So this is going to be negative 1. Let's get 3a subtract 1. And what else then now I am going to have, right? So they said I am going to square my a. Whatever that I have here in my a, right? Whatever that I have here in my a, now it's going to be squared, right? So which means in my a, I have my 3a, right? So this is same as 3a squared. And what is going to be my 3a squared? This is same as 9a squared. Can you see that, right? So which means here it's going to be 9a squared. Then now, secondly, they said the sign, remember this is negative, the sign here is always going to be positive, right? It's always going to be the opposite sign of these. Now, this is a multiplied by b, right? So, which means now in this case, because my a is 3a and my b is what? It is 1, which means this is going to be same as what? This is same as 3a multiplied by 1. Can you see that one, right? So, which means this is going to be same as what? This is going to be my same as my 3a. And lastly, now what is that I'm going to have? Now I'm going to have my b squared, which is this now squared, right? Now this is same as negative 1 squared. And what is going to be my negative 1 squared? This is still going to be same as positive 1. Okay, so now this is how I am going to factorize this one. I know probably this might still be, you know, a little bit confusing now, but as soon as we do the second and the third, then you are going to be fine, right? Now I want us to look at this one, right? Now, I want us to look at this. Now, look at this one. Here you are having your a, you are having your a cubed subtract 1 over 8, right? Now, can you see that this is also a different of cubes, right? Why am I saying that? Number one, I want you to look at this. Can you see that A is cubed, right? Can you see that A is cubed? And 1 is also a cubed number. And also 8 is a cubed number because 2 cubed gives us our 8, right? So which means even here we are going to apply the same thing, right? We are going to apply the same laws there, right? So which means here we are going to obviously open the first bracket, small brackets, and the big brackets, right? And how are we going to do this, right? Now, firstly, find out what is the square root, what is the cube root of the first term, and what is the cube root of the first term here? This is same as A, right? And then what is the cube root of this? This is same as, now what is the cube root of 1? It's 1. What is the cube root of 8? This is same as over 2, right? So which means this is same as A, 1 subtract 1 over 2, right? This is A subtract 1 over 2. And then now what else then now are you going to do? Now from the formula, you square the A, right? So which means this is going to be what? You square the first term, right? So which means this is same as my A squared. Oh, it's okay. Now remember the sign here, it's negative, which means here I am going to have my what? My positive sign, right? And what is it that I'm going to have here as my next term? As my next term, what is that I'm going to have here? This is what I'm going to have. Remember, they said it's A multiplied by B, right? So what is A multiplied by B in this case, which means what I'm having here, this is A multiplied by 1 over 2, right? And what is A multiplied by 1 over 2? Remember, that's what they said, right? It's A multiplied by B, which means this is going to be same as what? This is same as A multiplied by 1, which is same as A over what? Over 2, right? Or if you don't want to write it that way, you can still write it as 1 over 2A. Still one and the same thing, right? This is still the same as 1 over 2A, which is same as what? A over 2. Right. And then now, lastly, now, what is it that I'm going to have in my last term? This is same as negative 1 over 2, everything squared. Can you see that one, right? So, and when I do that, which means this is going to be same as what? This is going to be same as positive 1 over 4. Now, it's again, this is what I am going to have here as my equation, right? Which is going to be my 1 over 4. Now, so let's look at our number 9 now and see in terms of what is it that we can have in number 9, right? So in our number 9, we are having 3k to the power of 6 subtract what? 1 over 3. Altogether. Now, if you are looking at this, I think you can see from where we are standing that this is not either your difference of 2 squares or a difference of 2 cubes, right? So what is the best thing that now we can do in here, right? So I think now from here, we can start by getting rid of our what? Of our denominator here, right? So if let's say we want to get rid of this fraction, right? What is it that we can do now to get rid of this fraction? We can multiply both sides by what? We can multiply both sides by 3 so that these 3 and this 3 cancel, right? So when you say 3 multiplied by 3 this side, you are going to have 9k to the power of 6 subtract 1 altogether. And now what is it then that you are going to have here in 9 k to the power of 6 subtract 1? Now from here, this is going to be same as what? Now 9 and also 1 are the difference of 2 squares, right? So which means now from here, I can then open my 2 brackets, right? So this is going to be same as my 3k to the power of 3, right? 3k to the power of 3 altogether, right? And then now in this case, it's also going to be 3k to the power of what? To the power of 3, right? Because look, if I say 3k, if I say 3k to the power of 6, of 3 multiplied by 3k to the power of 6, right? Remember, 3 and 3 gives me 9. Multiplying powers of the same base, you add the exponents, which means this is going to be 9 to the power of 6, right? So that's why I am doing that when I am factorizing, right? And now what is going to be your 1 here? So this is going to be a 1 and also a 1. Remember, because this is a difference of 2 squares, the other bracket is going to be negative and also the other bracket is going to be positive, right? So this is how we are going to go about in solving this question, right? Now let's look at our number 10. In number 10, you're having 12 subtract 26a, right? 12 subtract 26a. Now subtract 10a squared. Now, what is the best thing that can be done here, right? Now, from here, I want to start by writing this in what? I want to start by writing this in your into your what? Into your quadratic expression, right? Which means this, I can write this in ax squared plus bx plus c, right? So which means now here I can change this and say this is the same as negative 10a squared. This is going to be minus what? This is going to be minus 26a, right? Minus 26a, this is plus 12, right? And then now from here, I can then now look for the number that is divisible everywhere here, right? So, and already I can see that all these numbers are divisible by what? By 2. So which means I can take out 2 as a common factor here. Let's say I take out negative 2 so that I get rid of the negative in the what? In the first term, right? So what is that I'm going to have here? I am going to left with 5a, all right? So this is going to be 5a squared. And then now from here, when you say now what is going to be 26? Isn't that 26 the same as 13? This is same as 13 times 2, right? So which means this is going to be same as plus. Remember, there's a negative here, right? So and here it's negative. So this is going to be plus 13, because when I say negative 2 multiplied by positive 13, then I get my negative, right? It's because of this negative that is going to affect everything that is going to be in my brackets here, right? So this is going to be 13a, and then this is going to be plus 6, right? This is going to be minus 6, right? Because I'm looking to have my positive at the end. So this is going to be my negative 6. How to get, right? So basically now that's what I am going to have here, which is going to be this one, right? And now from here, what is that I'm going to do? I'm going to start with my first term, right? Remember my 5a squared, right? This is a prime factor, which means a5 consists of 5 as a factor, and also what? And 1. Okay, so which means now what is it then that I'm going to do now from here? Which means now I'm going to open my 2 brackets, right? So this is going to be same as negative 2. So this is negative 2 into brackets. This is going to be 5a. Then the other bracket is going to be same as what? This is going to be same as a. And now what is it then that you are going to have here? So this is going to be same as my what? Now this is 5a and a. Now I am looking for the what? I am looking for the factors that when I either multiply with, they are going to give me 13, right? When I add them, right? For an example, remember I already have 5 and also 1 here, right? So what are the factors of 6, right? Now I can look at the factors of 6, right? And say I have 1 and 6. I have what? I also have 2 and 3. Now here, really, it's nothing much when you factorize this. This process that you are doing here, it's going to be a trial and error process, right? So now for an example, what is that I'm going to do now from here? Let's see. Now, if I can say I am looking for my 2 factors that when I multiply both of them, they are going to give me what? They are going to give me 13 when I add them, right? So when I multiply the factors and add them, they are going to give me 13, right? So let's look at this 2 and 3 for an example, right? Because look, if let's say I say 5 multiplied by 2, what is that I'm going to get here? This is going to be 10, right? Now, if I am looking at this, this is going to be same as what? 1 multiplied by 3. This is going to give me 3, right? So then what is that I'm going to have in here? This is going to be same as what? When I add these two, right? When I add these two, is going to give me what? This is going to give me my 13. Or I can still use 5 and 3, right? And also, right, 5 and 3, and also my what? And also my 2 and 1. Okay. So, but now let's start with this error, with this first one, right? Let's say I am using this one here, right? Let's say I am using 5, or rather 2 here, right? Let's say I am using my 2 here, and also I'm using my 3 here. What is that I'm going to do here? Look, if I multiply this one and this one, let's say this is going to be positive, right? What is that I'm going to get, right? These first and last term, can you see that I am getting my 15a, right? And if I say, let's say this one is negative, right? If I multiply negative 2 with a, this is negative 2a, right? So can you see that at the end, now when I say 15a subtract 2a, what is that I'm getting here? This is what? This is 13a, which is what I am having here, right? And when I multiply back the negative 2 again, and also with the what? With the 3, I am still getting my negative 6, right? So which means these are the perfect factors that I am going to use here, right? Again, so basically that's how you're going to determine that, right? So which means this is same as negative 2 into bracket. This is what? Actually, this is the answer. I'm not sure why am I rewriting again, because this is the answer for this particular question. Oh, it's okay. So I am hoping that all of this makes sense and you can be in a position to answer all these types of questions whenever you are given, right? So thank you very much for listening.